Hi everyone, so today we're going to start a new lesson all about triangles and right triangle trigonometry. But before we start the trigonometry part, we're going to talk about Pythagorean theorem. Pythagorean theorem is a formula that says a squared plus b squared is equal to c squared. And we use the Pythagorean theorem and on right triangles, so the triangle definitely has to be right, but we can use it to find a missing side or to determine if a triangle is right. So for this triangle that we have up here, we would have a side A, a side B, and a side C. And it doesn't matter which side is which, there's only one that's really important, and that's the side C. So your side C has to be what we call the hypotenuse of the triangle. And the hypotenuse is always the long slanty length, or the length that is opposite of your right angle. So if you find your right angle and then go straight opposite of that, that side has to be your side C. I don't care what your side A and B are. Like I could have had the height be your A and your bottom be your B. It doesn't matter as long as your hypotenuse is your side C. And like I said, we use this Pythagorean theorem to determine missing sides of right angle or right triangles, or also to determine if a triangle is right. And we're going to do all of that in the example. So let's get started with those. The first example, we have this triangle with sides 4, 9, and x, and we want to solve for x. So the first thing I'm going to do is label my triangle A, B, and C. And once again, the only one that matters is your side C, which is opposite of the right angle. So I've actually already drawn an arrow right here to represent the opposite of the right angle, which means that this side is side C. And then the other two sides, it doesn't matter. We're just going to put one side as A and the other side as B. So I'm going to start with my formula, which is a squared plus b squared is equal to c squared. Then we're going to replace the a, b, and c with the numbers that we know they are. So a squared turns into 4 squared because a is equal to 4. B squared turns into 9 squared because b is 9. And then c squared turns into x squared because c is x. And the goal here is to solve for x. So now it just becomes an algebra problem. And let's start by simplifying. So 4 squared is 16, 9 squared is 81, and then x squared just stays x squared. Now we can actually add 16 and 81, which gives me 97. So now I have this equation that says 97 is equal to x squared. Okay, great. So we have 97 is equal to x squared, but we don't necessarily care about what x squared is equal to. We want to know what x is equal to. So to figure out what x is equal to, we've got to get rid of the squared, and to get rid of the squared, we square root both sides. So when we square root 97, we got this. We square root x squared, we get this. The square root and the square on the x cancel each other out. So I just end up with x on this right side and then square root of 97 on the right. Now, potentially, I could plug the square root of 97 into my calculator, and when I do that, I get about 9.8. But for this self-check, I want you to leave your answers in simplified radical form. So your final answer for this question is that x is equal to the square root of 97. The square root of 97 can't be simplified in that radical form, so we just leave it at the square root of 97. All right, so that's one way we can solve for a missing side. Let's go through another example where instead of solving for the hypotenuse, we solve for a different side. So we've got this example number 2 where our sides are x, 5, and 7. And once again, it's a right triangle, so we can use the Pythagorean theorem. So I'm going to just start by writing out the Pythagorean theorem. A squared plus b squared is equal to c squared. And then let's label our triangle A, B, and C. So the first thing I'm going to do is label C. That's the easiest thing to start with because that's the one that's the most important. And C is opposite of your right angle, which means that your side that's 7 is your side C. Now the other two sides, it doesn't matter. I can label them A and B. So I'm going to say this side is A and this side is B. Okay, so we're going to use the Pythagorean theorem. Let's plug in the numbers that we know. So A turns into 5. We're going to say 5 squared plus b squared, but b is x, so we're going to say x squared is equal to c squared, which would be 7 squared. Okay, so now it becomes an algebra problem where we want to solve for x. We're going to start by simplifying the squared. So 5 squared is 25, x squared stays x squared, and then 7 squared is 49. All right, and we still want to solve for x squared. So to solve for x squared, we want to solve for x. So the first thing we want to do is get rid of x squared, or is get rid of the 25. And the way we do that is by subtracting 25 from each side. So when we subtract the 25, it cancels out over here on the left side, and we're just left with x squared. And then on the right side, we have 49 minus 25, which gives me 24. Okay, so now we have x squared by itself. To get rid of the squared, we have to square root both sides. So the square root and the squared on the x cancel each other out, and I'm left with just x, and that's equal to the square root of 24. Okay, now, once again, we can figure out what the square root of 24 is in decimal form, which would give us about 4.9, but we want to leave it in simplest radical form. So to do that, we're going to factor tree this guy because this one will simplify. So 24 I can write as 3 times 8, and then 8 I can do 2 times 4, and then 4 I can do 2 times 2. We circle our pairs, so we've got a pair of 2's right there, which means that that pops out of the square root. I'm going to write it over here. So we're going to have a 2 that pops out of the square root, and then on the inside of the square root is what I wasn't able to circle, which ends up being this 3 and this 2, because those are the edges of the branches, but didn't get circled because they don't have an extra pair, which means that I have 3 times 2 on the inside of my square root. So I can simplify this out to be that x is equal to 2 square root 3 times 2 is 6, so 2 square root 6, and this is my final answer in simplified radical form. Okay, so that's how we solve for a missing leg length rather than a hypotenuse, but both work the same way. We just have to subtract if we're looking for a leg length rather than a hypotenuse. Okay, let's go through the third example. On the third example, instead of asking you to solve for a missing side, I'm asking you to decide if the triangle is a right triangle or not. So once again, we're going to label our sides A, B, and C, but notice on this triangle, there is no right angle that we can find so that we can find our side C. So what we have to do is figure out the side C is always your longest length, or the longest, the biggest number. So what I'm going to do is I'm going to plug in these square roots and get a decimal version for them to determine which side would be my longest side, and that side has to be C. So the square root of 82 is about 9.1. So I'm going to write approximately 9.1 up here. Then we're going to do the square root of 226, which is approximately 15.0. So excuse me, based on that, the side 15, we have a side length of 15, a side length of 9.1, and a side length of 12. So that side length of the 15 has to be our side C. So I'm going to use our equation a squared plus b squared is equal to c squared. And we're going to assume that this side, if it works, would be side C, and then the other two sides can be A and B. Now, when I plug them into this Pythagorean theorem, what I'm doing, I have 3 numbers, and I have 3 spots for those numbers. So instead of like solving for a side, what we're going to do is plug them in and determine if the left side is equal to the right side. And if that is the case, then yes, it is a right triangle because the Pythagorean theorem worked. Now, if the left side does not equal the right side, then it is not a right triangle because the Pythagorean theorem didn't work. The other thing to consider is that even though we got decimal approximations for the sides A and C, we're going to use the actual square roots because that way it's not an approximation. So we're going to replace the A with square root of 82. So we got square root of 82 squared plus B is 12. So we're going to say 12 squared is equal to C, which is the square root of 226 squared. All right, and now what we're going to do is just simplify the left side and then simplify the right side. So on the left side, the square root of 82 and the square root and the square on the 82 cancel each other out. So this just ends up being 82. You could plug that into a calculator to double check, but I can guarantee that they'll cancel out and you'll just end up with 82. Plus 12 squared is 144. And that's going to be equal to, now we're going to simplify the left side. The square root and the squared cancel out on the 226, so we're just left with 226. Now what we have to do is figure out, does 82 plus 144 equal 226? And when I plug that into a calculator, yeah, so this side gives me oh my goodness, this side gives me 226, and that's equal to 226. So yeah, 226 does equal 226, right? That makes sense. And so because that makes sense, then yes, this is a right triangle. We can say, yes, right triangle. But if for some reason, like if you did this whole thing, but instead of getting 226 on both sides, you got like 100 is equal to 226, or 225 is equal to 226, anything that wasn't equal to each other, then no, it's not a right triangle. Okay, and the last example, what we're going to do is find the area of this triangle. So to find the area, there's no right angle here, so we can't necessarily use the Pythagorean theorem yet. But what we can do is break this triangle in half by just cutting it down right down the middle. When I cut it right down the middle like that, then I create two right angles, a right angle right here and then a right angle right here. So now I have two right triangles, and I'm going to draw them out like this. We're just going to draw one side. So here's one side of it. And we know that this side is 7. And then the bottom side, we know that the entire triangle has a bottom of 8.8. But I just cut it in half, right? So the bottom of this new triangle would be 4.4. Now the reason why we do this is because now what we can use, because we have a right triangle, we can use Pythagorean theorem to solve for the height of the triangle. And once we solve for the height of the triangle, then we can use it to find the area. Because if you remember, the formula for area of a triangle is area is equal to 1/2 base times height. So first we need to find the height, and the way that we're going to do that is with the Pythagorean theorem. So the Pythagorean theorem once again is a squared plus b squared is equal to c squared. And then remember we're going to label our sides a, b, and c has to be the hypotenuse, which is opposite of the right angle. So this is our side c, which is 7, and then a and b can be whatever ones we want, that are left over. So when we plug that in, we're going to end up with 4.4 squared for a plus h squared for b is equal to 7 squared for c. Now let's solve this for h by doing 4.4 squared, which gives me 19.36 plus h squared, because that won't simplify yet, is equal to 49, which is 7 squared. Okay, so we want to solve for h. First thing I'm going to do is subtract the 19.36 from each side. And we end up with, let's see, 49 minus 19.36 gives me the h squared is equal to 29.64. And then to get rid of the squared, we would square root each side. So we end up with h is equal to, because the square root and the squared cancel each other out, I'm going to get a decimal approximation for this one. Gives me about 5.44. Or we can, again, if we didn't want a decimal approximation, it would be left as the square root of 29.64. Okay, so that's our height of the triangle. Now that we know the height of the triangle, I can write it down on my original triangle. So I'm going to write it as the decimal approximation, 5.44. I know I just had a whole conversation about not using the decimal approximation. For the area ones on this self-check, you can use decimal approximations because you're going to get some really gross numbers anyway. And so I'm expecting for on the self-check for you to round your answers for area to the nearest tenth. Okay, so now we have this area, now we have this triangle and we know the height. Because we know the height, we can use this area formula. The area is equal to 1/2 base times height, which means the area for this triangle is equal to 1/2. My base has to be my entire base, or the entire bottom, which is 8.8, times the height, which I just found, which is that 5.44. And when I plug that in to my calculator, I end up with that the area is equal to 23.95. And that would be my final answer. So as you can see, the Pythagorean theorem is really useful in a lot of cases. But remember, the Pythagorean theorem only works if you're using it with right triangles.